So the question here is a BJT biasing circuit is shown in the figure where VBE is equal to 0.7 volt and beta is equal to 100 full stop. The quiescent point values of VCE and IC respectively full stop, and this is the circuit given here and their answer is given in their four options as a ABCD. So we have to find out the correct answer, and this is the question they had asked in GATE 2024 for electrical from the subject of analog. So here if you'll see that if you'll analyze this circuit, this is the question based on that biasing of the BJT by using that voltage divider bias. So here for this purpose, like we can apply Thevenin in this one part of this circuit, and then how this can be redrawn, this part can be redrawn in this way. So this is here VCC is equal to plus 12 volt. This is R2. This is R1 having 100 kilo ohm. This is R2 is equal to 50 kilo ohm, like that. So this point we have to apply the Thevenin here. So under this point we have to apply this Thevenin. So we will get it here. VTH will be what? This VTH is equal to R2 divided by R1 plus R2 into VCC. So this R2 value it is 50k divided by this R1 is 100k plus 50k into VCC is 12 volt. So if you do this simplification, you'll get it here. This VTH is equal to 4 volt. So we got it here. This VTH is equal to 4 volt. And now we have to calculate their RTH. So RTH will be what? By that time, whenever as per the procedure of the Thevenin, we have to consider that all the voltage source should be at the ground, so that this R1 R2 will be in terms of like parallel to each other. So here we will get this RTH will be what? This RTH is equal to R1 parallel to R2. It means this will be R1 into R2 divided by R1 plus R2. So here this R1 is 100k into R2 is 50k divided by 100k plus 50k. So this will become here as 100 by 3 kilo ohm. So we got it here, this RTH value, we got it 100 by 3 kilo ohm. So now we can apply this Thevenin to this circuit, then we can redraw this circuit and this will appear in this way. So this is the VCC which is given here as a plus 12 volt. This is RC value which is given here as a 2 kilo ohm. This is RE value which is given here as a 1 kilo ohm, and this is RTH value whatever we got it here as a 100 by 3 kilo ohm, and this is the VTH whatever we got it here as a 4 volt. And this is VCE. So as we know that as a quiescent point, what we need to find out? We need to find out VCE and the current passing through this, what is called as a IC. We need to find out these two part, VCE as well as this IC. and their beta is already given in the question. So we can apply this KVL in this inner side of this loop. Then we can get it here like IB value, and IC is, we need to find out beta is given. So we know that this IC is equal to beta times of IB. So beta is given as 100, and we need to find out by solving this inner part of the circuit that we need to find out IB, so that by that way we will get this IC value. Then as a second part of the question we need to find out that VCE, and then that is called the quiescent point for this given circuit. So now here we can apply that KVL in this inner loop, so that we will get it here. This input is like, we can write it here, VTH is equal to VT RTH into IB plus VBE. So this is our VBE. VBE plus IE into RE. So this IE, as we know that in terms of beta, this can be written as a 1 plus beta times of IB. So here this IE RE can be written as a 1 plus beta times of IB into RE. So from here we can make the separation of this IB. So what will be this IB? This IB is equal to VTH minus VBE divided by RTH plus 1 plus beta times of RE. So now we need to substitute these values here. VTH is how much? It is 4 volt. VBE already given in the question as a 0.7 volt. This RTH we got it here as a 100 by 3 plus beta value is given 100, so this will become here 101 into their RA is how much? As a 1 kilo ohm. So now their order will become here as a milliampere. Because of this kilo it will go to the numerator, so that it will become 10 raised to minus 3. So for that we can substitute here as a milli, so that their order of this IB will become here as a milliampere. So now if we'll solve this, then we will get it here by solving this. We will get this IB is equal to, this IB is equal to 3.3 divided by 134.33 milliampere. This is our IB. This is our IB. So now we have to find out IC. So IC is equal to beta times of IB. So beta times of IB means like this will become here 100 into 3.3 divided by 134.33. So this IC is equal to, this IC is equal to 2.4566 milliampere. So we can approximate this up to 2 digit in the decimal part. So this can be written 2.46 milliampere. This IC is equal to 2.46 milliampere. So now if you'll see that in the option part, then this IC is equal to 2.46 is given in two options here. If you'll see that in option A and option B, both is having 2.46 here. It means that which answer will be right, either A or B, that we can verify by calculating VCE. So now our target is to calculate their VCE, and for that purpose how we will get that? So here this VCE we can easily find out from this outer part of the circuit. So we can apply that this KVL in the outer part of the circuit, and before of that we have to calculate their IE. So IE will be what? That is called their emitter current, so that we will get this as a IE is equal to what? This IE is equal to 1 plus beta times of IB. So this will become here as a 1 plus beta, beta is 100, it means it will become here 101 into IB is what? This IB is 3.3 divided by 134.33 and their order will be milliampere. So we will get this IE is equal to, this emitter current is equal to 2.48 milliampere. 2.48 milliampere. This we have to use it further for the calculation of VCE. So now I am going to calculate their VCE value. So as per that, we can write that, like we can apply the KVL to the right side, or we can say that output part. So this can be written here, VCE is equal to VCC minus IC into RC minus RE into IE. So VCC is given here as a 12 volt minus this RC is given to 2 kilo ohm. So here kilo and milli will be cancelling to each other. So simply we can write it here. This IC is 2.46 and RC is 2 kilo ohm. So we can multiply this by 2, milli kilo gets cancelled, minus this RE is 1 kilo ohm into IE, whatever we got it, 2.48. So kilo milli gets cancelled. So their unit will be volt, their unit will be volt. So after doing this, this will become 12 volt minus 7.4 volt. So we will get it here as a 4.6 volt. So VCE, we got it here. This VCE is equal to 4.6 volt. IC, we got it here as a 2.46 and VCE is 4.6 volt. Now we have to check these two values with the option. So if you'll see that this VCE is 4.6 volt is given in option A and IC is 2.46. So by this way, option A is the right answer for this question. And by this way, this is the end of the explanation for this question. Thank you. So the question here is, in the given circuit, the diodes are ideal full stop. The current I through the diode D1 in milliamperes is, fill in the blanks, and answer should be round off to 2 decimal places full stop. And this is the circuit given for this question. And this question they had asked for GATE 2024 for electrical branch from the subject of analog circuit. And from the analog circuit, this question has taken from the topic of multi-diode circuit. So in this circuit, as per the information given, we have to find out the value of I here, which is passing through this D1 diode. And before going into the detailed analysis, we don't know about that whether these two diodes are in the on state or off state. So first of all, we have to check it with that by making the assumption whether it is in the on state or off state. So I'm assuming here that this both the diode D1 and D2 is in on state, and for the ideal diode we know that this diode will be acting here as a short circuit. So equivalent to this, I had made that their equivalent circuit. So for this D1, this is here showing D1 and this is short circuit here, and this is showing here as a D2 which is also short circuit under the on condition for the ideal diodes. So here, by making this inspection, we can easily say D1 is in the on state. The reason behind that, for this D1, their anode side is connected to plus 3 volt and cathode side is connected to ground through this 1 kilo ohm of the resistor. So due to that reason, we can say that D1 diode is in on state, and here this voltage will become here as a 3 volt. It means what I am trying to say that this node voltage will become here as a 3 volt because of this shorting of this diode. So there is no drop across the diode, so the same voltage will appear as a 3 volt at this node point also. So now here, like for this D2 diode, if you check it here, like this voltage, their anode side voltage is not known. So what I had taken as a Vx. So for this D2 diode, their cathode side voltage is 3 volt, which is connected through this 1 kilo ohm, and their anode side voltage is Vx, which is not known. So if Vx value is coming more than 3 volt, that is giving the guarantee that D2 diode will be also in the on state, whatever we had made the assumption initially. And by that way, we can calculate the value of this I in terms of milliampere. So we can make this node point, whatever we have taken as a P node point, I can say it here at this node point. So now we have to apply KCL at node point P. Apply KCL at node P. So what we can write it here, that I is coming towards this node point, so we can write it here as a I plus this another current is I1, so I plus I1 is equal to outgoing current at this node point is I2, so I plus I1 is equal to I2. Now this I we have to find out what is this I1. So I1 will be what? Vx minus 3 divided by 1 kilo, so that their order will become now in terms of milli ampere is equal to this I2 will be what? 3 volt minus 0 divided by 1, and their order will be also milliampere. So here in this one, we can say that this I is equal to what? This will become here as a 6 minus Vx in terms of milliampere just after solving this equation. So let's say this as equation number 1. So we have to calculate Vx and substitute in this equation number 1, then we will get the value of I here. So now we have to apply that KCL at this Vx node point. So if you'll see that for this Vx, what is the incoming current? It is I3, and outgoing current from this junction is I1 and I4. So now apply that KCL at this point. Apply KCL at node Vx. So we can write it here as a I3 is equal to, this I3 is equal to I1 plus I4. What is this I3? So their supply voltage is 10 minus Vx divided by 1, and their order will be milliampere is equal to I1 is what? Vx minus 3 divided by 1, their order is also milliampere, plus I4 will be what? Vx minus 0 divided by 1, and their order will be also milliampere. So if we'll see that this milliampere will be cancelling to each other from all these terms, so that we can calculate this Vx value. This Vx value will be what? By solving this, you'll get it here. Vx is equal to 13 by 3 volt. Vx is equal to 13 by 3 volt. So if you'll see that 13 by 3 volt, it will be more than 4 volts. So now here if you'll see that this Vx value, whatever we got it here, this Vx value, it is 13 by 3 volt, which is greater than this 3 volt. So due to that reason, now we can say that this Vx is greater than 3 volt. So this is saying that our D2 diode will be also in the on state, and whatever we had made the assumption, it is right now from this point. So here now we have to substitute this Vx value in this equation number 1. So what we will get it here, this I is equal to 6 minus Vx milliampere. So Vx value is 6 minus, this will become here 13 by 3. So this will become here, LCM is 3. So 18 minus 13 by 3 milliampere. So we will get it here 5 by 3 milliampere. So this will become here as a 1.66 milliampere. So we got the value here as a I is equal to, that is passing through this D1 diode. So I is equal to 1.66 milliampere. This I is equal to 1.66 milliampere. So this is numerical answer type of the question, and here we have to find out, like their unit is already mentioned here as a milliampere, so we need to substitute only their numerical value. So whatever it is coming, it is 1.66. So the final answer for this question is 1.66, and by this way, this is the end of the explanation for this question. Thank you. So the question here is, a difference amplifier is shown in the figure full stop. Assume the op-amp to be ideal full stop. The CMRR in terms of dB of the difference amplifier is, fill in the blanks, and answer should be round off to 2 decimal places full stop, and this is given their circuit for the corresponding question, and this is the question they had asked for GATE 2024 for the electrical branch from the subject of analog circuit, and the topic here is application of op-amp. So in this question, what they had asked about that CMRR. As we know the definition of this CMRR, we can find out this as a ratio of AD by ACM, where AD is called differential mode gain and ACM is called common mode gain, and in terms of dB, this can be obtained. CMRR in terms of dB we can find out as a 20 log this AD by ACM. So it means first of all we have to find out this AD as well as ACM, then only we can find out this CMRR. So this AD we can find out from this circuit. So this AD we will get it here as a AD is equal to A2 minus A1 divided by 2. So this A2 is the gain of this amplifier under non-inverting mode operation of this op-amp, and A1 is the gain of the op-amp under the inverting mode, and this ACM we can find out here as a A1 plus A2. So it means first of all we have to find out this A1 and A2 to get this AD and ACM. So now we have to do this. So whenever we are considering this V in 1, by that time V in 2 should be taken at the ground as per the superposition rule. So here whenever more than 2 sources acting at a time, then if it is voltage source, we have to keep that another voltage source to the sorted, so that there is no current or there is no response obtained due to this V in 2 whenever we are considering this V in 1. So due to this V in 1, here we will get this due to V in 1, their output we are considering as a V output 1. So this will be given here as a minus RF divided by R1 into V in 1. Now if you see that here what it has given the value, this RF value it has given 101 kilo ohm divided by this R1 is 10.5 kilo ohm into V in 1. So this kilo ohm gets cancelled, and VO1 divided by V in 1 is giving their corresponding gain. So here we can consider that gain as a A1. So this A1 is equal to VO1 divided by V in 1. So that is becoming here as a minus 101 divided by 10.5. So this is giving here as a 9.61. Let's say this as a equation number 1. So what we got this A1 value, it is 9.61. What we have to use it here in this equation. So now again we have to calculate that this A2. So A2 is the gain of this circuit because of this V in 2. So whenever we are considering this V in 2, by that time as per the superposition, V in 1 should be short circuited so that this terminal will be at the ground. And now here if you see that this V in 2 is having the 2 resistor here, so there will be the current flowing in this way, and here we can calculate their V plus voltage, so that we can easily find out this V plus is equal to what? V plus is 10. V plus will be the voltage across this resistor here. So 101.5 kilo ohm divide by 9.5k plus 101.5k into V in 2. So this V plus will be what? So this will become here 101.5 divided by 9.5 plus 101.5 into V in 2, because kilo will get cancelled from the numerator as well as denominator, and we have to use this for calculating VO2. So now here now we can calculate that output due to V in 2. So that output we can consider it here as a VO2. So this VO2 is equal to what? 1 plus RF divided by R1 into V plus. So here this will be 1 plus RF is what? This RF is 101 kilo ohm divided by R1 is 10.5. So what is this RF and R1? This is our RF. This is our RF. This is our R1. So 101 divided by 10.5. 101 divided by 10.5, kilo gets cancelled into V plus. So V plus is what? V plus is whatever we got it earlier as a 101.5 divided by 101.5 plus 9.5 into V in 2. So we will get this, the gain due to this V in 2, or we can say that gain of that op amp under non-inverting mode of operation, we will get it here as a A2 is equal to, this A2 is equal to VO2 divided by V in 2 is equal to, doing this calculation, so this will become here as a 10.619 because of this, and because of this it will become here 0.9144. So we will get it here, this value ultimately 9.710 as a equation 2. So now use this equation number 1 and 2 to get that their AD and ACM. So here what will be their AD and ACM? So this AD is equal to A2 minus A1 divided by 2. So this will become here 9.710 minus 9.619 divided by 2. So this value will become here as a 9.66. Let's say this as a equation number 3. Now this ACM will be what? This ACM is equal to A1 plus A2. So this A1 is minus 9.66. This A1 is minus 9.619, or we can take it at 9.61, plus this A2, whatever we got it, 9.71. So we got this value as a 0.10. Let's say this as a equation number 4. Now we can use this equation number 3 and 4 in that previous one. So CMRR, as per the definition of the CMRR we had seen, this CMRR is equal to AD by ACM. So this AD value we got it 9.66 from this equation number 3, and ACM is 0.10. So this value will become here as a 96.6. So this CMRR in terms of dB, this CMRR in terms of dB is equal to 20 log 96.6. So this value is becoming 39.69 dB. 39.69 dB. So even though in this question they had asked about that CMRR in terms of dB, so their value we got it 39.69. So this is the numerical answer type of the question. So here the answer for this question, like dB is mentioned in the question itself. So this can be written, their numerical values only 39.69. So the final answer for this question 39.69, and by this way this is the end of the explanation for this question. Thank you.